Hello dear students, in this video we are going to discuss about the topic hypothesis testing. As you know, in statistical technique research, we have to use hypothesis testing. We can use simple methods of analysis like percentage analysis, mean, etc. But in order to get a more meaningful and accurate result, it needs hypothesis testing. So what's hypothesis? Hypothesis is just an assumption about the population. You can simply say it's a just assumption about the study. Okay, so the study based on this hypothesis or this assumption is known as hypothesis testing. It's a method used to determine whether there is enough evidence in a sample of data collected to conclude the result that is a certain condition is true for the entire population. For example, if you are testing the sample mean, if you are taking some sample and testing the sample mean, we can construct an hypothesis that the sample mean and the population mean are same. We are just doing the calculations or research using this sample. By using this hypothesis, we can conclude that if we accept the hypothesis, we can conclude that the population mean and the sample mean are same. Okay, so hypothesis is just an assumption that we are creating before going to a research. It helps to infer that a certain condition is true for the entire population. So we apply this hypothesis testing only in the case of sample testing. Okay. So hypothesis testing is very useful to make informed decisions based on the data and evidence rather than just relying on intuition or assumptions. So here we can study which are the different two types of hypothesis. There are mainly two types of hypothesis. First one is null hypothesis and the second one is alternative hypothesis. This null hypothesis is represented by H naught, and we are doing the computations on the basis or the study on the basis of this H naught. Okay, then it is assumed to be true unless there is sufficient evidence to reject it. Okay, it is assumed to be true unless there is a sufficient evidence to reject it. We always this null hypothesis like this. There is no significant difference between sample mean and population mean. Oh, okay. In that way, we are always creating this null hypothesis. Then the second one is alternative hypothesis, which is the original hypothesis, and it is represented as H1 as the opposite of null hypothesis. If we are rejecting the null hypothesis after study, we can accept alternative hypothesis. Okay, so if we reject the null hypothesis, we will accept the alternative hypothesis. And the steps we will study how we are accepting and rejecting the hypothesis. Okay, here is an example. Here is the steps for hypothesis testing. Suppose we have to test whether the population mean and sample mean are equal. You have to compare the marks of degree students in Calicut University who are doing BCom. Okay, so in order to that, you are not able to collect the data from the whole graduates in a year. You have to do it regarding the 2023 pass out batch, but there are lots of students, so you cannot do a population study. It's very time consuming, and so you decided to conduct a study on the basis of sampling technique. Okay, so you first of all you have to set a hypothesis. Okay, that is I'm selecting 200 students, and on that way, suppose I am selecting 200 students and I have to conduct a study on the basis of these 200 students, and I have to prove that most of the students are scoring above 60% of mark. Okay, so I'll set a null hypothesis. There is no significant difference between the average marks of sample and population. Okay, there is no significant difference. I'll set the null hypothesis, and I will set another hypothesis, that is the alternative hypothesis, just opposite of this null hypothesis. There is significant difference between the sample mean and population mean. Okay, then after that I have to determine the level of significance. Level of significance is the error region or the critical region. Simply we can say, if you are concluding on the basis of 95% confidence, then there will be a 5% of chance of error. Okay, if you are doing 100 times a thing, there may be a chance of failure of 5 times. It means that there is a level of significance of 5. If there is a chance of failure of 10 times, it means that there is a chance of or there is an error of 10%. If the error is 10%, then the confidence will be 90%. If the error is 5%, then the confidence level will be 95%. Okay, in that way we have to determine what's our level of significance and the confidence level. Then next we have to decide the text statistics. That is which formula or which method you are adopting. You can use t-test is there, z-test is there, ANOVA is there, then chi-square is there, regression and correlation is also there. So you can determine which method is using for this statistical study. Okay, which type of testing are you using, whether it is univariate, multivariate. If it is univariate, which one? If it is multivariate, if it is bivariate, which are you selecting? You have to decide. After that you have to calculate the test value using the equation. For example, there are equation. For example, if you are testing the association using the chi-square test, you can use the equation of chi-square test. Sigma O minus C all square divided by E. It's the equation. Another way you can use this z-test, t-test, correlation, regression, whatever may be. So in this step, in the fourth step, you have to find the value of the test statistic. Okay, that is the calculated value. Then we have to take the table value. I will show you the table. Table value for the there will be a statistical table for every corresponding calculations. If you are using chi-square, there is a statistical table for chi-square. If you are using t-test, there is a statistical table for t-test. Okay. If you are testing the analysis of variance, that is ANOVA, there is a table for that. So you have to find out the table value. While taking the table value, you have to consider the level of significance and the degree of freedom. Okay, degree of freedom is just the number of independent attributes. And so after taking this, after taking the table value, and we have already calculated the computed value or the test statistics value, we have to compare both of these. That is, we have to compare the p value and the we have to compute the statistic value that we find out using the equation and also this table value. Okay, then reject or accept. Here we have to conclude whether to accept or reject the hypothesis. Okay. If the table value is greater and the calculated value is less, after using the equation you get the value as 1.56, but the table value shows 2, that is the table value is higher and the calculated value is less, you have to reject it. Okay, otherwise you can accept it. If the calculated value is higher than the table value, that is the table value is the value that we get from the statistical table. Okay, if the calculated value is higher, you have to accept it. Okay, so if you accept, you are accepting the H naught that we have set in the first step. If you are rejecting it, you are rejecting the H naught and accepting the alternative hypothesis. So while accepting the H naught, we have to accept the first H naught, that is the null hypothesis. Okay, if you are rejecting it, we have to accept the second one, that is the alternative hypothesis. So this is the steps in hypothesis testing. Okay, so I have said there is this level of significance. And the first one, you can see that in both sides there is a rejection region. Okay, that is, there is a chance of error, that the mean variable may be less or be greater. There is a chance of error. This is a two-sided error. Maybe greater or maybe less. The population mean and sample mean we are comparing. Suppose we are taking 5% level of significance. 5% level of significance. So there is a chance of less value or more value. Okay, there is a chance for error. Just saying that. That is a rejection region. In the second, you can see that if you are taking 5% level of significance, that is 95% confidence. Okay, so on this basis we have to take the table value. I'll show you the table. This is a significant table for two-tiled t-test. The first column is the degree of freedom. Usually we take n-1. If there is only one group of sample, then we can take n-1. Okay, then there is a, when the level of significance is 10%, 5%, 1% is given. From that you have to take the value. Okay, if it is 5% and degree of freedom is 9, then the table value is 2.26216. In that way you can find the table value. Okay, then the next one is the important topic, that is type 1 error and type 2 error. There are mainly two errors that can happen while we are doing the hypothesis testing. There is a chance of error. Even though we are fixing the level of significance, there is a chance of error. Okay, when we are rejecting a null hypothesis, when it is correct, okay, you can see that that is, type 1 error is rejecting a null hypothesis that is actually true. That is type 1 error. Okay, reject a null hypothesis when it is true. That is a type 1 error. If we are rejecting a null hypothesis, it is false. There is no matter. There is no problems in our study. We already set a wrong hypothesis. We reject it. There is no error in that. And the next case, the null hypothesis is true, but we fail to reject it. Okay, null hypothesis is true, but we fail to reject it. That means we accept it. Okay, so it is correct. The hypothesis is true, we accept it. There is no error in that. In the last one, null hypothesis is false, but we fail to reject it. We accepted that. So it is an error. So there are mainly two types of error. Type 1 error, reject the null hypothesis when it is true. For example, we can say a medical test may indicate that a person has a certain disease, but in actually he may not have. This is a type 1 error. Okay, and the type 2 error, the null hypothesis is false. Okay, but we fail to reject it, or we accepted it. We already set an hypothesis that he is suffering from certain diseases. Okay, it is a false hypothesis and we accepted it. Okay, this is the two types of errors. You can see here also, H naught is true, we accepted it, there is no error. H naught is false, but we accepted it. Okay, that is failed to reject. There is an error, that is type 2 error. It is represented as beta. Then H naught is true, but we nicely reject that H naught. That is type 1 error. It is usually represented as alpha. Okay. So this is about type 1 error and type 2 error. There are some causes of type 1 error and type 2 error. When the sample size is small, or there is a poorly designed experimental study. Then lack of control groups in our experimental study, inadequate measurement, or we are not collected the proper data. These are the major causes of Type 1,